reporting the result of a calculation to the proper number of significant figures. So now that we know what significant figures are, we can determine how many significant figures there are. When we actually go to report our answer, how do we know how many significant figures to use? So there are two sets of rules, right? Well, actually three, I guess. There's one, there's two, there's three. Okay. So when we're using multiplication and division, and by the way, please do not use the verbs times, right? We're going to use multiplied by or divided by. When multiplication and division is being used, the term, meaning out of the numbers that you're actually multiplying or dividing, the term with the least number of significant figures, which equates to the least accurate measurement, right, will determine the number of maximum, right, maximum number of significant figures in the answer. So we're looking to our least accurate measurement to figure out how many significant figures should be in my answer. Now, to be perfectly honest, it's helpful to underline the digits in the least significant number as a reminder. You guys know from my first year chemistry course that I'm a real big fan of actually writing things down, physically getting yourself involved, because it just makes your brain work a little bit more. So when I look at these two terms that I'm multiplying, I see that the 1.4 has the fewest number of significant figures. It is the least accurate measurement. And so this number right here, the 1.4, is going to limit the number of significant figures that I can use. Now, when I put this into my calculator, and by the way, this is a free smartphone app that you can get on your phone. I'm not getting paid by Samsung to use their phone. I just have one. But if I do this calculation, 4.56 multiplied by 1.4, a calculator is going to tell me a whole bunch of stuff. Okay, a whole bunch of stuff. Now this is calculator vomit. It's calculator puke. It's just bleh. Because a lot of people don't understand that when your calculator actually does its thing, it's assuming that you're using exact or counting numbers. It assumes that there are infinite significant figures when it does its calculation, so it can't help you with significant figures. So this big long number gets spit out, and I don't want to use this big long number. I only want to use two significant figures, right? Because that was the number of significant figures in my least accurate measurement. And so I have to round to this number. Now, old school rounding rules, the number right behind that is an 8, so that makes me round up to 6.4. When using addition and subtraction, right? Please don't say, what we'll talk about it later. But when using addition and subtraction, the term with the least number of decimal places. Notice how when we were talking about multiplication and division, we had to count the number of significant figures. We're talking about addition and subtraction. We count the number of decimal places. And the least number of decimal places is going to identify the least accurate measurement. And we'll see in both of these situations, we're really just trying to find the least accurate measurement. That's really what we're looking for. Because our answer can't be more accurate or more precise than our least accurate or least precise measurement is the rule we're going for here. It looks a little bit different for multiplication and division versus addition and subtraction, so that's where we're going over this. So I have these three numbers right here, the 12.11, the 18.0, the 1.013. And I look at all these terms and I see that this 18.0 only has one decimal place. And so that means that when I go to give my answer has to have only one decimal place. And so this is going to be the number that limits how many decimal places I can use. And so I plug all of these into my calculator just like normal, and I get all this calculator vomit. But I understand that since this limiting term says I can only have one decimal place, I need to round to this spot. Now the number right behind it is a 2, so that tells me to keep it the same. Don't round it up to 2, keep it the same. And so when I go to report my answer, I report my answer is 31.1, and we are golden. There is a third situation which we will use in this course. It's when we start to calculate pH. And the reason that this has its own thing is because it's calculated way, way differently than multiplication and division or addition and subtraction. So let's talk about it. So pH, which we won't do for a while, don't get me wrong. It'll be a little while later. The number of significant figures in the least accurate measurement determines the number of decimal places on the reported pH. Number of decimal places, not the number of significant figures, not the number of digits, the number of decimal places. So the number of significant figures in the least accurate measurement determines the number of decimal places on the reported pH. Right now, in most chemistry textbooks, there's a big old hoop-de-doo in your appendix that'll actually tell you why that's the case. Here's what it looks like. Maybe we measure a pH of 1.45. Okay, it's pretty low, pretty acidic. Maybe we measure a pH of 12.45. All right, that's pretty basic. It's pretty high on the scale. And using the rules that we've looked at so far, we might think like, oh, this one has 3 significant figures, and this one has 4 significant figures. But that's not the case on either of them. Both of those would be incorrect. And now the reason is, in this pH example, which is the third of the 3 situations here, is that a pH is logarithmic. You use a logarithmic calculation, and that changes the rules. Using a log is not addition, it's not subtraction, it's not multiplication, it's not division, so we use slightly different method. So going back to our definition, the least accurate measurement, again, always the least accurate measurement, determines the number of decimal places on the reported pH. So how many decimal places do I have here? 2. How many decimal places do I have here? 2. So it turns out that both of these have 2 significant figures. Right? Now, understanding logarithmic calculations can get a little bit tedious and annoying, and we're not going to do a whole bunch of them, even though we will do our fair share. But this idea is pretty simple. Okay, this idea is pretty simple. The hardest thing for you is going to be remembering to use this strategy. Right? We got 3 different strategies for reporting significant figures. To use this strategy when you encounter pH. And yes, I will give you a reminder when we get there.